Hi, I'm George Woodbury from College of the Sequoias, and in this video we're going to talk about average rate of change over some interval. So let's say we've got some quantity that we measure, some quantity y that we measure at a certain point x, and then sometime later we come back and measure again, and we're trying to find the average rate. Well, this is really just going to be the slope of the line between the 2 points. We're measuring how much y has changed compared to how much x has changed. And that gives us a rate, right? A fraction compares the units in the numerator to the units in the denominator. So we're going to start with an example where in 1990, we were told the average income per person in the US was $39,900. So in 1990, 39,900 was the average income per person. Now I know that those are my x and y's because I read ahead a little bit and it says find the average rate of change in US income per person. Income is y and the time, is x, right, for this time period. So that's my first ordered pair. The second ordered pair says by 2020, that had increased to $63,200. So there's my second value, second ordered pair, and I can find the slope. It's going to be 63,200 minus 39,900 over the change in time, 2020 minus 1990. So when we subtract in the numerator, that's 23,300. Just do that on your calculator. In the denominator, it was 30 years. And I'm going to add the units here. It's $23,300 over 30 years. So when I simplify this and divide this out, I'm going to get an average rate of change of so many dollars per year. So I go to the calculator and I divide 23,300 by 30, and I want to go to two decimal places here because we're talking about money. So dollars and cents, two places for cents makes sense. So here it was 766.66666. That's going to round to $766.67 per year. So on average, in total, income went up by 23,300, but if we're trying to get that on an average per year basis, we divide by 30 years, $766.67. Now we can also do average rate of change for a function over a certain interval, and so this formula is equivalent to the slope formula, f of b minus f of a over b minus a. A and b are your x1 and x2. When we substitute them into the function, those are your y1 and y2, f of a and f of b. So it's really the same idea. I've got one here. Find the average rate of change for this function, f of x equals 3x minus 7, over the closed interval from 2 to 8. So I know my a is 2 and my b is 8. I need to figure out what f of a and f of b are. So let's start with f of 2. That's going to be 3 times 2 minus 7. That's 6 minus 7, or negative 1. Then I try f of 8. That's 3 times 8 minus 7. 24 minus 7, that's 17. And so the rate of change, the average rate of change, is going to be f of 8 minus f of 2 over 8 minus 2. And we've just seen that that's 17 minus negative 1 over 8 minus 2. 17 minus negative 1, that's the same as 17 plus 1, or 18. In the denominator, 8 minus 2 is 6. And when we divide 18 divided by 6, that's 3. That should be no surprise because when we think about the function f of x equals 3x minus 7, that's a linear function. And the slope of 3 is the rate of change for that function. It's constantly changing at 3 at a rate of 3 per 1. Now, when the function's not linear, it's not so cut and dry. So we've got one more example here. F of x equals x squared over certain intervals. And so I'm going to begin with a quick sketch of this function. We know that this is a parabola that goes through 0, like so. And so the values of x, right, if we pick -1 and 4, that's going to give us a different result than if we pick -3 and -1, and so on. So these are all going to be different. In A, part A, the value of A is -1, the value of B is 4. So the average rate of change is going to be f of 4 minus f of -1 over 4 minus -1. F of 4, the function is just to square the value. So 4 squared is 16 minus -1 squared is -1 times -1. That's a positive 1. Over 4 minus -1 is the same as 4 plus 1. So what we really have here is 15 over 5, or 3. So when we went from the point -1, 1 up to the point 4, 16, the slope of that line that connects them, and that line is called a secant line, S-E-C-A-N-T. So it's not the actual function itself, but it's a line that connects 2 points on the function. That secant line has a slope of 3. That tells us that the rate of change for this function over that interval is positive 3. It went up by 15 units as we went 5 units to the right. For the second one, A and B are -3 and -1. So we've got f of -1 minus f of -3, all over -1 minus -3. F of -1 we've already done. We just did that a minute ago. When we square -1, we get positive 1, minus, when we square -3, we get positive 9. So that's 1 minus 9 on the top. In the denominator, we've got -1 plus 3. And so this is the same as -8 over 2, or -4. So here, when we go from the point -3, 9, down to that point -1, 1, that has a slope of -4. So it's dropping 4 units for every 1 unit to the right. All right, one last one to do. A is -2, B is positive 2. So we're going to take f of 2 minus f of -2 over 2 minus -2. F of 2 means to square 2, so 2 squared is 4, minus -2 squared is also 4, so the numerator is 4 minus 4. In the denominator, 2 minus -2 is the same as 2 plus 2. So we end up with 0 over 4, or 0. So the average rate of change here is 0, and if we zoom in on a graph of this function, here we were going from -2 to positive 2. That secant line is just horizontal. And so that's why the rate of change is 0, because the function ended up at the same value of y. It didn't go up or down. Even though it went down a bunch first and then back up afterwards, it's where did it end up? And it ended up at exactly the same height. So the slope of that secant line is 0. That means the average rate of change is 0. All right. That's it for average rate of change and its ties to slope. I'll see you in the next video.